Thank you for joining me today. I'll briefly give you a presentation regarding the transport engineering project that I've chosen in a relevant area. The information was received through an industry colleague with permission from fiscal engineers for the Delta Food road upgrades. This particular road upgrade was, the design was finalized late last year and will soon be implemented. It is actually for paved road of an existing tarred area or asphalt area. Part of the information received was some DTM information, digital terrain models with point files, etc. Those particular files were a bit of an issue to pull in. That's the top plot here at the top, the TOT files especially. Then she had to ask another industry colleague if they could use Civil Designer, which I wasn't using in this case. I used Civil 3D. If he could break it down, he did, and managed to send me a TIM file and a survey file, as well as some aerial images, which I used later on in the report. Part of the report was also geotechnical investigation, again received with approvals from them. However, they did redact other information in some areas. Then on the other side of the screen, we do see test pit locations throughout. So it's like 10 test pits were done. You will notice that they did not do test pits at the two interleading roads, and we had to do interpret what we were getting in that area based on TP7 and TP8. So we had some test pit profiles done, which you can see is mainly silty gravelly sands, with excavations down to about, on average, 1.4. In some cases, we would go 1.8 and 2 meters. These were excavated with TLB. Thus, if they haven't got those depths, it kind of shows how hard the material was. We have some DCP tests, which I'll go into more depth a little bit later in the presentation. They're just quick excerpts from the report. Very low pH conductivity, which is great, especially if you have some rebar in some of the areas, for example, the culverts and drains. Then issues on site, no expensive soils were encountered, no collapsible soils were encountered. No compressible soils really were encountered. Excavation classification was excavated classified to soft intermediate, so an average of 1.4, and then after 1.4 they would need something a little bit heavier. On this particular project, they probably wouldn't go past 1.4 too much, except for if they were putting in the culverts. So the contractor would have to take that into account. As you can see in these images, the very gravelly material that they were cutting straight through an existing asphalt layer. The drainage patterns, it did come out that groundwater seepage wouldn't be an issue, which I interpreted in my report to mean that we wouldn't need subsurface drainage in this particular case. Then I reviewed all the information and put it together. We have 3 roads that we have joined together, the red being road 1, the blue being road 2, and road 3, taking up about 3.8 kilometers. This information was brought in, and the terrain model was created. Then I cleaned up the files, the surface a bit. Actually cleaned it up a little bit too much. Later on when I did the corridor, I had to include a little bit more layer, surface line to call it. Then the design CBR, they did do some, however, they only did it in 3 areas, and this wasn't enough for what I needed. So I eventually, and later on I'll speak more about it, I eventually did some DC correlations for DCPs. I did some estimations of traffic volumes for the expected implementation in about 20 years' time, I said. And it turned out with a growth rate of 6%, then it turns out that we needed 1.64 lanes in each direction, which I equated to basically 4 lanes, 2 in each direction. So there's a little bit of a safety barrier there. Then in the pavement designs, I used TRH4 and SAPEM from Senrail. Just again, I relisted all the information I took out of the geotext, so it was condensed into one area. Then getting to what I was saying about the DCPs. From experience, the DCPs work best in nearly any conditions. Troxler tests are great, and I'm sure that those CBRs I showed initially with Troxlers. However, the problem with the Troxler is it doesn't work well in a confined space. So unless they don't mention it, unless they drilled a hole to put the Troxler through, I don't trust those results too much. I would trust these DCPs more because they could put it directly in the hole or just next to it. It works great. So according to Klein, which is a South African back in the 80s, he realized there's a correlation between the penetration rates and CBRs. So based on this formula that he had, I took these DCPs and we converted to CBRs. As you can see, there's some very high CBRs and some very low ones. The main problem areas in and around DCP 8. Then I also did a projection of traffic data over the expected area. Worked out my heavy vehicles and the total amount of E80s was expected. I did choose later on, I'll explain it, I did choose an ES100, so 100 million, and we are slightly over here. So even though the SDP is for 25 years, I suspect we're probably going to have a better life for more like 20 years itself, and yeah, probably some rehabilitation before then. Then I took all the information that I got with the CBRs, worked out the subgrade class, worked out what was needed for the subgrade itself, and then also the test bits that had the issue was actually test bit 3 and test bit 8, which 3 was the worst. Then with the TRH4 catalogs, I chose two different what I didn't mention on the previous slide is that the cement bases weren't really a possibility. They said mainly due to costs and everything, but they did say granular bases and hot mix asphalt bases. And the only two that will really work for us is the one shown on the screen now and this one. Thus, I had the alternatives at the relevant changes. I had to choose 3. This one on the end is because we had to chemically stabilize the issues. Then what I've decided to do is I actually decided to go with a more granular base, mainly because of the materials that were found in the borrow pit and which is on site, because I assumed that the hard mix asphalt being in a more rural area might be harder to get hold of. So I decided to choose these pavement designs. Then also on the drainage side of things, I decided that we were just asked to do a conceptual design. So I just took where the main issues would be where the surface flow would actually hit the roads themselves. So we're putting curb inlets in the road because we are coming both sides, putting catchment drains on the eastern portions of roads 1 and 3. And then we're putting at the northern portions of roads 1 and 2. And then we do have culverts that run through the road. So as you can see, we've got our catchment drains, we've got our KIs, curb inlets throughout, and then here is one of our culverts. There's again road number 3 with its catchment drain. Then you can see roads number 2 and 1 with a catchment drain in this corner. It's just behind my camera here. Then we've got another catchment, culverts, and culverts. And we've got this catchment here. Better image of the culverts is it runs directly through, and thus will take the water further out into the lands because the slope of the land runs basically northeast to southwest. Then I took all the information that we had at hand out of the TRH 17, TRH 26, and the GDG geometric design guidelines from Sanral. That I put again contains everything together to what we would need. Then I chose my road reserves, which in this case would be up to 60 meters. And then my cross-section dimensions, funny enough, the minimum shoulder width is 1.5, but because of the curb being so close to the thing, we eventually went with 2.1. Then the design speed of 120 km an hour seemed too high for a rural setting. That's actually adopted an urban class 2 design speed. With the amount of people that live in the area, even though it is rural, it's semi-urban in a way. So that's why I went with 80 kilometers an hour. Then I did my calculations, and it turns out with the negative E value, I didn't need super elevation if we stuck to 210 mile radius and a design speed of 80 km an hour. And then what I did is I just decided to consolidate everything into a nice table as per requested. And then this comes into play later when I input it into the software itself. Then I did horizontal alignment, where after pulling in the data and identifying the center lines of the existing road, I then laid out all 3 roads. Then I started doing manual calculations for the PIs as well as the curves, etc. Throughout. Then on road number 1, we had a big issue. The 210 mil curve would not fit at all. Thus, decided the best option would probably be to force a reduction in speed, and thus we could change to 110 mil radius. That was the only option, other than a lot of expropriation with the community, which would have upset them. After doing that, I started implementing all the design information that was required, stopping sight distance, passing sight distance, etc. Then I also developed the cross-sectional assembly. I inputted all the relevant information designs for the pavements throughout. Then what I did is I did an alignment to all 3 roads, but I did get a few errors, so it took me a while. I did manage to clear all those errors, mainly by adjusting the start and the end of some of the curves, etc. Then I moved on to vertical alignment, where I basically took the road alignment, horizontal road alignment, and then I created the long sections or they call them profiles here in Civil 3D. I took those profiles, and then once I had the profiles, I managed to then draw in some fixed tangents to the top and the bottom point, and that basically gave me my vertical alignment. But then I also had to adjust it up and down and create some sag curves based on the K values of 33 and 25, and then adjusted our vertical alignment accordingly to try and balance out cut and fill. That was done through all 3 of them. Then I created a corridor on each of the alignments that I could then apply our different pavement designs to, based on what the DCP results were giving me. And thus I could economize, instead of blanket saying everything, I economized that as much as possible where I could in the relevant areas. Finished off the thing. As you can see, there's a lot of areas where that original cleaning up of the surface had to be changed, which I did ultimately do. And I generated our cross sections in the thing. To generate the cross sections, I had to do a new sample line throughout the area. That sample line then allowed me to basically generate cross sections at every 40 meters as requested, but all in one go instead of one at a time. That saved a lot of time. Then I created the mass haul diagram as requested. And then this is where I started hitting a snag with the software itself. The mass haul diagram was showing no cut and fill. This was confirmed later on when I opened up the total volume tables, and it said 0. As of about 20 minutes ago, before I did this recording, it was just before we submit, I got to a point that I could not get this changed before submitting, so it is in my documentation as 0. But from personal experience, I know that is incorrect. I just could not get this thing to work. And I hope that doesn't penalize me on this, but I thought to still present it in my report and in my design that I did do a mass haul. It's just that the software issues didn't allow me to actually get it done the right way. Then just a quick overview of the drawings I presented. Then we did a basic drawing showing the layouts and the levels. I see my north area is missing at the top here, but I'll make sure that's in the current report. Just showing all the drainage locations, the drainages, etc., in the cross-sectional area. Then I've got my typical alignments throughout, vertical alignments. Then for roads 1, 2, and 3, then I've got all my sections. I put it, this is all for road 1, so it's road 1 sections with mass haul and the volume tables. Same as for road 2 and road 3. Then I went to my report. First I went to the manual calculation check. I created an Excel document to do a quick check. Just inputted the calculations onto the Excel doc and wrote the formulas here on the side. There you go. There's my mouse formulas to give us the thing. So all you basically need is you need your PI, your central angle, and your radius in this calculation. And in this calculation, if you've got your BC instead of your radius, then you can work everything out. And this was added into the report. This is just the first 4 pages just to indicate this presentation will obviously go in just now. Then I did do the honor page itself, which I signed and then scanned in to add to this document. Got a list of contents and also list of figures, tables, and the references I used. Thank you very much for your time. I'm sorry I'm 2 minutes over time. I hope this is sufficient for this course. Thank you.